Okay, this is lesson 26, and I'm going to just, so we don't get overwhelmed with all the details and we just hit the really important stuff. Lesson 26, I'm going to talk about briefly, and then I'm going to just boil it down to the one formula that you need to know for friction. So first of all, you notes talk about static friction and kinetic friction. Static friction is the friction that exists between two objects that are not in relative motion to one another. So chair sitting on the floor, static friction. Kinetic friction is when one of the objects is moving. And so, and you probably figure out intuitively, if you're trying to push something, it takes the most amount of force to get it moving. Once it's moving, then it's a little easier. So there's less friction. So kinetic friction is always a little less than static friction. Okay, that's really all you need to know for that, the difference between static friction and kinetic friction. And then it goes, gives you some notes on what causes friction. And here is the form. This is what you need to know for friction. You need to know this. You need to know this formula right here. And that formula says force of friction equals mu. Mu is the coefficient of friction between two surfaces. It doesn't have any units, and it's obviously different between different surfaces. For example, this friction between your car tires on the concrete is very high. It would have to be, otherwise your car will be sliding all over the place. Just think about if you tried to drive your car on a hockey rink. There's a lot less friction because of the ice, because of the coefficient of friction between ice and your tires would be a lot less. So for some things you want a lot of friction. For other things, you want very little friction. And there's some really good examples on the next page. It says you don't have to memorize this table. So here's some examples of static friction and kinetic friction. And you can see the one that has the absolute lowest friction are the synovial joints in humans, for your elbows and your knees. You want very little friction there. Otherwise, they're going to wear out very quickly. And moving is going to be very difficult. Okay, so then there are all these examples here, but I don't think we need to go over all those examples. All you need to know is how to use this formula here. F force of friction equals mu times Fn. And a reminder that Fn is the normal force. The normal force. And so if I have, let's say, a box resting on the ground, the normal force is up. And what is down? It's gravity. And since the box is neither accelerating up nor down, then the normal force must equal the force of gravity. So more often than not, when you're doing this formula, the force of friction equals mu times what it turns out to be Fg or mg. So you often end up with this derivation of the formula. The force of friction equals the coefficient of friction, mu, times the mass of the object times the gravity, which is negative 9.81 meters per second squared. And so if you know how to use that formula there, you're good for friction. You can look at the examples in your notes to go over them just for interest, but you're not going to be tested on those ones. It's the next lesson that you would probably be that would be most useful for you, or not the next lesson, actually the next example. So let's go to this one right here. Okay. This is a pretty intense example. There are no questions like this on your assignment. However, I think it's worthwhile going through this question because it's one of the more intricate questions in the force unit and has a lot of little details which you would probably forget. So let's take a look at this question. Actually, I'm going to stop the video and make this into two short videos instead of one big long one. So we'll just stop this, and then the next video will be this example here. It's a long, complicated example.